Okay. So let us say this is speech. Okay. Now I am basically first trying to tell you that in speech, what do you see? What is the basically, what are the features basically which you can extract and tell that okay, this is male and a female. So in speech, you see there is something called as fundamental frequency, right?
Okay, yeah.
Which is also called as pitch.
Pitch.
So
Yeah.
usually the female will have a high pitch because their voice is uh, like male have usually lower pitch. Like females have more that what do you say, narrow pitch sounding voice,
Yes.
right? I mean we
Yes.
have more shrill voice, right? So
Yes.
anyway, so that basically that fundamental frequency and that pitch is one of the important factor which you can extract and tell that okay, it is so a male fundamental frequency lies between 70 to 150. Female lies between, it is range basically, female it lies between 160 to 260.
It is a decibel or
It's
what is
hertz.
70
It's hertz
hertz? Okay.
frequency, number of cycles per second in the fundamental in
Cycle.
cycle, yeah. It is not
Mm.
the harmonics. I mean, see, when you are speaking you might be speaking at 150 hertz. Okay, let's say you are speaking at 100 hertz. So when you are speaking, it's not like you are only speaking 100 hertz. You are speaking lot of frequencies, but 100 hertz is the dominant one. And with 100 you might be speaking 200 also, 300 also, 400 also. So those are like the harmonics of 100, first harmonic, second harmonic, third harmonics, like that. Okay. And
Okay. Okay.
I mean that's how we speak actually. Like I will tell you, 100 hertz sound and 200 hertz sound will sound similar, and 100 hertz sound and 101 hertz sound will be very different. That's that's an um, that's a totally different thing.
Uh,
You may think that 100 and 101 will be similar,
how
but
it
that's
is?
not
Yeah.
the case. Yeah, but that is not the case.
But how it is?
Huh?
So what's the reason behind? What's the reason behind this? Like
Reason is
similar.
like, see, the any frequency f, then 2f,
Mm.
3f,
Mm.
4f, these are called harmonics. Okay.
Mm.
So these harmonics, like in the instrument also, na sa re ga ma, you see. So
Yes. Yes.
there will be a sa re ga ma for like high tempo, then there will be a low tempo, right? So I mean with tempo I mean at different frequencies. So if you see a piano, on the left side it will be a very husky voice. As you
Mm.
go
Yeah.
on the right side it will be very shrill and very
Smooth voice.
high pitch, yeah, yeah, high pitch voice. But the sound is same, the sound is sa only, sa 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 sa, like sa will be there only, but it will be, it will be very at different frequencies, and those frequencies are actually nothing but harmonics. So f will sound similar like twice of f or thrice of f, four times of f, because those are like the harmonics.
Yes. Yes. You're right.
But the sound, I'll say f and f plus 1, they will be totally different, because their cycle will change. Like what I will tell, see, this is like something like this. Okay, so let's say this is like 3 cycles. So the 3 cycles, now the sixth cycle voice will be similar to this, because maybe the same stuff it is doing it in half or in multiple times, but But at the same time, if something is like 4 cycle, it will be totally different. I mean, from physics point of view, I don't know what is the actual reason behind it, but this is the funda of harmonics actually. You can see it in instruments and all also. There will be definitely some reason for this also. Okay.
Okay, okay,
But
okay.
what I was trying to say is there are a lot of such features in speech: energy, entropy, pitch, fundamental frequency, harmonics, MFCCs, right? And lot of such features which you can actually extract, and you can model your application. You can model your gender through that. Okay. So this was all about feature extraction, and what we are doing from speech is here. I will tell you. See, this is speech. Huh. Now in speech, what is done? This is say, let's say 101 second speech. Okay, how many second?
One
1 second.
second.
Now this 1 second speech, how it is processed actually? Like if I say that I will take pitch, or let's say frequency, I am extracting any feature of speech. Now will I process whole speech altogether, or I should process this whole speech in parts, or I should do what? See, in speech your frequency is always changing. See, it's always changing, right? Here it is something else, 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 right? So basically what I am telling is your frequency will always be changing. Now how to capture that frequency? So what people do is people will process this speech in segments, and this is very common approach. I am telling you, very very common. I mean, everybody does that. If you don't do that, you will get wrong results. In speech processing, you always process your speech in frames. You never do it all together. Okay? You always process speech in frames. And how
Yes.
you take these frames? These frames are like 25 millisecond frames. Now, why 25 millisecond? Because 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 in 25 millisecond, for 25 millisecond, your speech is constant. It is assumed that whatever you are speaking na, your voice will be
Mm-hmm.
at a constant frequency for 25 millisecond, and then only it will vary. So each 25 millisecond we try to capture, and on from this 25 millis, let's say this is 25 millisecond. So from this 25 millisecond you extract whatever features you have to extract. Then again next 25, then again next 25, again next 25, again next 25, again next 25, like this you will go. So 25 millisecond you will select, then you will shift this window little bit, and then again 25. Shift this window little bit, then again 25. So it is like 25 millisecond is the frame size, and shift is of 10 millisecond. This is a very common norm, I am telling you. You can take it 30 also, this 15. You can take it 40 also, this maybe 20. So, but generally, the frame size cannot be very high. Max what I have seen is 40 millisecond. Okay,
Okay, okay,
so
okay.
that is where you process the speech in frames, and here in this particular um, application, what we are going to do is we are going to extract MFCC features. What we are going to extract? MFCC feature.
MFCC.
This is like male frequency coefficients, cepstral, This is, all DSP funda, digital signal processing funda. This you may not need to understand a lot, but you should know what features you are going to use. So this is mil frequency substral coefficients. So basically in any, let's say 25 millisecond speech, these are the 12 coefficients, actually 12 features. These are the 12 feature which tells the about the shape of your, frame, or yes, a signal. Okay. This will actually tell you
Okay, okay,
the how the, speech is varying. Okay. So this is like the extract feature with the MFCC features. And finally, okay, just to repeat the thing, I will again draw that. So you have male speech, you have female speech. Okay, let's say you have male speech, you have female speech somewhere. We will train two Gaussian model, right? One this and one this. So let's say we put Gaussian model like this, two component only, like this. Now whenever a test data will come, I will find the probability for male and I will find the probability for female, right?
yes,
And whichever will come highest, that will be identified as the gender. Okay.
okay,
So basically what you have to do, first you have to extract the features, then model a Gaussian mixture model, then find out the probability and get the score. Whichever will be the highest, we will do that. Now let us come to the Python example. Python. Okay, let me first show you the data. Okay, so you can see this directory PyGender.
yes,
You see the training data.
yeah, training testing,
In training data, YouTube is there. So female, how many files are there?
five files.
Five
Mm,
files. If you see these five files, you will find that these are of 5 minutes. How much time?
5 minutes.
So each file is almost of 1 minute. Okay.
Okay,
Then mail also how much time? 5
five
minutes.
minutes.
5 minute 1 second it is, but yeah, it's fine. Okay. So basically what I am telling, I have taken male and female 5 minutes from YouTube. Okay.
Okay,
Now, now, uh, you see, uh, and in test data also, again I have a lot of files like this. Okay.
yeah, okay,
The files starting from M is of male and the files starting from F is the female. This, I will tell you, these files actually have been collected from a online demonstration which I have gave on, National Technology Day in Mumbai.
okay, okay,
So in Mumbai in 2017 only, uh, in Mumbai I have this National Technology Day was there in April or May somewhere. So I have shown the same software which I am telling these two small programs. These Using these two small programs only, I have built a UI, uh, a web application basically, and under that, I mean underlying this model was only working the same which I am going to show you, the same small code Python codes, but on the top I have made a good UI which I was just showing it to the kids, or the people who are coming out for the demonstration, 10 on National Technology Day, and they were on live. They were recording their voice, and I was telling their gender. I was predicting their gender through this. So, so these data I have collected from there only. Okay. So we will test it on how it works on their data. So let us see the training model. Okay. So see,
Okay,
this
okay.
is the path. Hmm?
Yeah.
This is the path to training data, male, right? And here what I am doing, I am going to this pi gender. I am so okay. Pi gender is basically the folder where I will save my model. This male GMM, female GMM. I told you, you have to create two models. One is male GMM,
Yes,
one is
yes.
female GMM. Okay.
Yeah.
Okay. So these are the two GMMs. Okay. Now now you see what I am doing. So this is a folder basically where I will write the model. I will tell you this program what it is doing. So I have taken all the files, okay, from this mail directory. Mail directory, the 5 files were there. Na? I have taken all the files. I have now what I have done for each file, for f in files or each file, I am reading that audio. Now you will see how are you reading an audio speech. So this is in SciPy library. There is a scipy.io.wave file. There is a read. Okay.
Okay.
So this read is there, and okay. So this I have read in audio, and now from this audio I am extracting this get MFCC features. These are the 12 features which I told you. Na, it will give me the whole vector. Okay, and this is like 12 feature vector for that whole audio. I mean 25 25 25 millisecond frame. You will say what is this get MFCC? Get MFCC is this definition which I have made. This is a MFCC library which I have used here. See this library will take an audio, then sampling rate, I mean the frequency at which it is sampled. I mean every audio has some sampling rate, you know that, na? Like the music ones will have a 48,000 sampling rate. The telephonic calls will have 8,000, like that. Sampling rate means
Okay.
when you are digitalizing the analog signal, how many samples you are taking in a second. Okay,
Okay, okay.
so like that. So see, anyway, you leave that SR. I'm saying just audio you
Hmm.
give. This is 25 millisecond frame size. This is shift. How many features do you want? So 13 features. Okay, 13 MFCC features I am calculating. Now, so this will give you those 13 dimensional features for each of the 25 millisecond frames in the audio. This get MFCC function. And now this get MFCC function will return this whole matrix, and that matrix you can keep on appending. Why keep on appending? Because all the 5 files are mail only. So basically I will append all the features of mail. Okay. So for from each file, whatever features are getting, I am appending it to make a huge matrix, feature matrix. For that, I am using a NumPy vstack function, vertical stacking. Okay, so like that you will after this whole loop for all 5 minutes you will extract features, and then it is very simple. See, this is the sklearn scikit-learn Gaussian mixture model. That Gaussian mixture model you just call. How many number of component you have to give? How many number of iteration it will go? And
13.
yeah, the covariance type. I mean, this is like when you do Gaussian. Na? In Gaussian, you have to give. There are two kinds of learning. One learning is this diagonal type, and one learning is full type. Okay, so basically in a speech processing case, we usually use diagonal only. Okay, because we consider that each cluster. See, when you do diagonal, na, you consider that each cluster is independent of each other. When you do full, then each of these cluster will be tied with all other. So that is not the case we consider. So we will take diagonal only. Okay, and
Okay,
then
okay.
this is like the whole clustering algorithm model initialization will do, and this is training. So whatever features you have extracted MFCC features in here, you just fit it through this GMM and dump it, save it, save it to the folder, that dest folder which I have taken. See, in this pygender, you save it as a pickle file. Okay, so from through C pickle I have saved it. Okay, now this thing you have to do it for female also and male also. Okay,
The
so
same
this is
same thing.
basically feature extraction.
Hmm.
This is model training, and this is saving the model. That's it. You have any questions or something?
Oh, same thing I have to do for
Yes, 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 yes. Same
female
thing.
voice.
Same thing you have to do for female also, because it's like you have to train two models, no? So you have to write here female, then it will take up the female
Yeah,
directory.
yeah.
Okay, so that's not a big deal. You can do that. Okay. In fact, I will train it here so that you can see. Although, let me show you the testing first, because I have already generated the model. No need to train this. I will show you how to train this. I mean, how I will show you by running this, but first let me complete this thing also.
Okay,
Wait, huh? I will show you the test file also. Now, what will you do in testing? Testing is again very simple, right? In testing, what is there? You have we have this gender evaluation exhibition dataset, right? On that, which I said
yeah.
that I will show you how to test this one. Okay,
Okay,
these files are the testing files, na? So on this testing file, what I am doing? I am doing nothing. Whatever GMM files I have written here, na, in PyGender. Okay, can will you give me just 2 minutes? I will. A call is coming. I have to answer it.
sure, sure. Not an issue.
Okay, I will just call.
Okay,
I will come back in 5 minutes. Okay.
okay. Not an issue.
Yeah. Hello.
Take your time.
हाँ मम्मी Yeah, hello. Hello, you there?
Okay. Yeah. Thank
Yeah,
you.
yeah. So what I was telling is, by these lines, I am basically uh, taking the GMM files, the full path, the absolute path of the GMM files, these training files basically, okay?
Okay.
And for these models, this is like from cpickle, I'm loading these GMM files, the
Okay.
absolute paths which I have taken. Na? So for file
Hmm.
name in this absolute path, I am loading the files, okay? So these are the two gender models which you have now, and this is the source path of the test data, or the files on the of the audio files on which I have to do testing, okay? So again, I am basically testing this thing. The absolute path I am taking in this files, this list, okay? And then what I am doing, you just, these are the labels, okay? Like there are 250 files. How many files are there in testing data? See, 250 items,
250
right?
files. Yes.
And out of this, the first half is female and the second half is male, okay?
Mail.
So like these are the females, which is like zeros, only zeros, okay? And these are like females which are ones, sorry,
Okay.
male. So the second half was male, right?
Mail. Hmm.
So these are the males. See, np.0, you know now what it does.
0 to
Suppose I
range.
give it 10, so it will make an array of 10.
In yeah.
Okay, and suppose I do it like this, a equal to this. So a will be this. Now I am saying that from 5 to 10, just make it 1. So like this.
Okay.
Okay. So so this is the array, right? Now now see, so this is like this. I have made a labels for 250 files, okay? First 120 is female and then 130 is male, okay? Like this. Why I have taken down the actual labels? So that I can then check the accuracy, like how many detected correctly and what was the actual labels. So I can get the accuracy, na?
Okay.
So for that thing I have taken this actual label, okay? Now you see what has to be done is, for each file in this 250 files, this whole list, I will be printing the file name, huh? I will be printing the file name because I will be splitting out the absolute path, just the file name I am trying to print here. Read that file, get the MFCC features, and then again I have two models, na? You see, I have two models, male and female. So again in a loop with both these model, I am getting that GMM model, and this is like scoring it with the features which you have extracted. This is the features which you have extracted from the audio,
Okay.
MFCC features which you have extracted from the test audio. So now these are basically the data points. Like when I say in paint, when I told you that these are the say 2 GMM. Now I have a data point X. So I will calculate the probability with this and this, right? So this X is
Yeah.
what? This is basically feature vectors. whose probability with these two models has to be calculated. So similarly, these
Yeah.
features basically, they're these are scored for this GMM. This GMM will be, let's say, female. Then in loop, the second model is male. So for male also it will be done. And then this is called as log likelihood. So whatever score is coming, na, that score,
Mm.
let's say in one test file, one audio file, there were say 100 frames. Okay. So for all the 100 frames, this likelihood will be calculated. And then for male also and for female also in loop, the whole probability will be added up. Like all the frames of that audio will be scored with male model summed up, that is called as log likelihood I. Then all the females, all the features, all the frames of that speech will be scored for female also in the next loop, and then their scores will be added up, and that will be the log likelihood 2. See, log likelihood is a list of two values, right? One will be a probability of male, one other will be a probability of female. And then you do simply argmax. Argmax will give you who is the winner, first zeroth index or first index. So that winner you can append, of course. And then finally you are printing that this file detected as gender means female and male, so whatever will be the index, that index. And scores also, the likelihood is scores, whatever here it is calculated now,
Mm-hmm.
that score also I am printing for female and male. I will show you. I will show you step by step so that you can, understand little bit more. I will show you how it does things. See, I will show you first what is this GMM file is containing.
Okay.
See, what will it contain? It will contain the model path, the absolute model path, right? Now I will show you what this uh,
Model.
models will have that GMM model, right? I will show you what this
Mm.
files will contain. Hmm. So this will contain the male and female GMM model. This will contain all the files which we are going to test on, and then the results. Let us see. See, for every file it is telling male, female, whatever it is. See, this is the confusion matrix. So out
Okay.
of 120 female, 119 female it has detected correctly. Only one female it was not able to detect. Out of 130 males, 16 male it was not able to detect, and 114 male it was able to detect. Okay,
Yeah. Yes.
so that is the one case. Then actually the thing which I wanted to show you, I will have to put some imports this. I will break it first, right? I mean, I will stop the execution here. See, see here I have run, na?
Mm-hmm.
So this
GM
print
files.
GMM files is giving me this female.gmm, the path of basically model, female.gmm and male.gmm, where it is. Okay. Now this print files is giving me all the file which I want to,
250 files.
yeah. Hmm. See all these files, female, these are the females files. Then there will be male files, all the files. And then I have exited basically. Okay. So from here, I will get the model, I will load it, and this gender is nothing but male, female. This is just a list. Okay. And what else? That's it. If you will see, if you want to see the scores, I will just show you. See, like this is the file which is printed, detected as female, detected as
Okay.
female, and then a slash n
Score.
means new line, and then scores
Score.
female this much and male this much. Now, what is this score? This score is, as I told you, this is likelihood that say what is the probability of X that it is lying in male model. So
Hmm.
probability of X lying in male component 1 plus probability of X lying in male component 2, probability of X lying in male component 3, like that. All the 8 components I have taken, male and female both. So that is there. Okay.
Okay.
This probability is calculated. And this probability is not taken a log also. Because sometimes this probability is so small that it is hard to represent, so people take it log so that the scaling is done. So when you take log, such a scores will come. Actually, this score, if you see na, if this is a very um, dot kind of score. I mean, if you say, let's say if your probability is 0.0001, first of
Hmm.
all, let me tell you, probability is always between 0 and 1. Agreed or not?
Yeah.
Probability is always between 0 and 1. Now
Zero
let's
and
say
one.
the
Yes.
probability comes out to be very small. So let's say 0.00001. Okay. So when you take a log, what will it come?
It's improve the score like
No, no,
instead of 001,
mathematically what it will come? 0.001. Let's say this is the
zero
probability.
point zero 0.01. Huh.
Let's say this is the probability 0.001. Now if you take a log, it will become minus 3,
Okay.
isn't it? Because 0.001 will be 10 to the power minus 3. And when you
Ah,
take
yes,
a
yes.
log 10 to the power minus 3, log 10 is 1.
Minus
So it
3.
will become minus 3 into log 10, right? Minus 3 into 1, right?
Yeah. It's minus 3.
Let's say this is the probability. It is this. When you take
Hmm.
log, it will become minus 4 log 10. So if this is base is 10, this will become 1,
And 1.
right? So like that it is coming minus this much. So it is like huge 0.000 huge zeros. And then also it is summed up value. Summed up means because for each frame I am summing up. I told you it is processed in 25 millisecond frames. So for each 25
Okay.
millisecond frame there will be a point. So for that point you will
Okay.
calculate the probability with male and female, right?
Okay.
And
So whichever is higher is detected as a male or female.
yes, yes. So in this you see negative likelihood mein you see the female is lower, right?
Hmm.
So in negative, this is the higher, na? Like in minus 2 and
Higher,
minus
higher.
3.
Actually, it's
Yeah,
higher side. Yeah.
yeah. In minus 2 and minus 3, minus 2 is higher, na?
Yes.
So that is the case.
Okay. Okay.
Got it? So like that, you see, I am getting the very good result on the evaluation, gender evaluation data set, exhibition data set. So you can demonstrate it also anywhere or something like. So this is basically a kudos application, you can say.
Hmm.
Small application
Yeah.
which you can
Small
build and
application.
maybe you can, yeah. Okay.
Okay. Fine.
So yeah, so this is it from this gender side. but this is like very this is a simple, application, simple, statement. I mean, there are a lot of real problems which you can work on and probably get a good, exposure in machine learning. So that's what I will suggest you now. Now you are
Mm-hmm.
done with ML, right? So
Yeah.
develop some hands-on coding in Python. Okay.
Okay.
And meanwhile you also enroll in that deep learning course. The assignment and everything is in Python only, so you will anyway
Okay.
need to
Okay.
learn Python. Now if you
Okay.
have already learned, or if you have developed codes and all, just learn Python, and let me
Mm-hmm.
know. Maybe we can start I mean, do some coding and try to implement this project, and see this how the codes are going on. Maybe you can go to that blog which I have shown you last time. You just
Yeah. Yeah.
go to that blog, take an application, a blog post. Each blog post will give you some hands-on coding only. So you can do that probably, and then you can come back to me. We can start a Kaggle challenge or something, just on machine
Sure.
learning
Sure.
basis. I mean,
Yeah.
not diving in, like maybe you can explore the machine learning models, I can explore the deep learning models.
Mm,
Okay.
yeah.
Anything will do. I mean, I'm just telling. Uh, so, but then you have to first. I will suggest, don't just rush towards this. First, try to improve your Python skills, and try to develop some small application, or on some small data set. Try to do things on in Python. Okay. Once you will get that
Okay.
confidence,
Okay.
na, then probably we can start. I mean, any of these things we can take. Okay.
Yeah, sure. 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 Let give me some time.
Yeah, sure, sure.
Let me cope up with Python and deep learning.
uh,
So meanwhile, we can definitely start up with this.
yes, 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 you first have some confidence on that, then we will definitely try to start.
Okay.
Okay. Lot of good.
You just share the
Hmm.
you share me that blog link because actually I upgraded my mobile,
Hmm.
so whatever WhatsApp data is there, which is not updated completely.
Okay. See, this is
Yeah, I'm
the
not getting complete backup. So
uh, see, this is the blog.
yeah, yeah, yeah.
Anyway, this
You
video is
just
recorded, so I will send you this video.
okay, not a problem.
You can see the website here also, and I have sent you in the chat also. Okay. So probably you can
Yeah.
see that, check it out, any of these applications, and then maybe you can basically, you have to first develop your skills in Python, so that you can do small things
Mm,
like
yeah,
file reading, file writing, listing the files in the directory. Those things you can
yeah.
do in Python. Probably then that will help a lot in
Arrays,
yeah,
arrays and other
array,
stuff.
numpy array. Yeah. Just to start, you can just go through the initial second or third video recorded session that was on
Mm,
introduction to Python only.
Python only. Yeah.
Okay.
Okay. Okay, then we'll meet up. I
Sure.
will update you on my deep learning and this Python coding.
Yeah, yeah, yeah. Sure, sure.